welcome to channel Knowledge of. Please subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry, and that is your chemistry for class 11th, and that is your class 24. We had done your 23rd class of the list chapter, that 23rd class where we had discussed last topic is your physical property. Today we're gonna start with discussing about the chemical properties in a detail, where in the last classes we had done about your group 13 element, that is the boron family, where we had discussed about electronic configuration, atomic radii, ionization enthalpy, electronegativity, physical properties. That were all five group element 13 element properties we had discussed. Today we discuss about the chemical properties. In that of course we discuss about atomic and physical properties of the group 13 element. But before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So let's get started. Chemical properties. In terms of chemical properties here, that's what we have to discuss. First, in detail we discuss about the oxidation state and trends in chemical reactivity. Oxidation state and trends in chemical reactivity. So in the same here, due to the small size of boron, the sum of its first three ionization enthalpies is very high. This prevents it from plus 3 ions and force it to form a only a covalent compound. That is your. But we move from boron to aluminium, the sum of the first three ionization enthalpies of aluminium, that is considerably decreases and is therefore able to form Al3 plus. So that is Al3 plus ions, and in fact that aluminium is a highly electropositive metal, and however down the group, due to a poor shielding effect of interventing D and F orbital, the increased effect nuclear charges that hold the electron tightly, which is responsible for the inert period effect and thereby restricting their participation in bonding. So for that a p block heavier elements, the shielding इसलिए that less, क्योंकि that the परत that वो हट जाता है, उसके बाद वो अट्रैक्ट करता है. So according to that, I just write it down for the that for aluminium, and of course after that the rest of the things that we'll discuss here. Aluminium is highly electropositive metal. Is a highly electropositive metal. So down the group, due to the poor shielding effect. Of intervening DNF orbital. The increased effective nuclear charge hold ns electron tightly, that is responsible for the inert beard effect, and therefore thereby restricting their participation in bonding. Now, as a result of this, only p orbital electron may be involved in class 3 oxidation state are observed, and the relative stability of plus 1 oxidation state and progressively increase for heavier element, where we have in thallium, that is plus 1 oxidation state is predominant, whereas the plus 3 oxidation state is highly oxidizing in character. The compound in the concentrations are more ionic and in those in a plus 3 oxidation state. In the same way, in trivalent state, that the number of electron around the central atom in a molecule of a compound of these elements, example boron in BF3, will be only 6. Such electron deficient molecules have tendency to accept a pair of electron to achieve a stable electronic configuration and thus behave as Lewis acid. The tendency to behave as Lewis acid decreases with increase in the size of down the group, where BCl3 easily accept an ion lone pair of electron from the ammonia for BCl3 and H3. So we just the tendency to behave the tendency to behave as Lewis acid decreases with the increase in the size down the group. Where BCl3 is easily accept a lone pair of electron from ammonia to form BCl3 and H3. So we'll go for it. BCl3 plus NH3, it forms BCl3 NH3. This is your planar, and this is your tetrahedral. Now coming towards the tetrahedral AlCl3 that achieves the stability by forming a dimer. So for that, by forming a dimer. So here we go, which is AlCl3. So first we draw Al, this is Cl, now another Cl, this is 101 degree, 79 degree, 118 degree, 2:21 p.m., 206 p.m. Here this is a bridge that and the dipole moment has been making in a tetrahedral. This has been the tetrahedral. In traveling state, the most of the compound being covalent are hydrolyzed in water, and for example, the trichloride on hydrolysis in water form tetrahedral, which is MOH4 minus species, and that the hybridization state of an element M is sp3. Aluminum chloride in acidified aqueous solution forms octahedral, which is AlH2O6 3 plus ion. In this complex ion, the 3D orbital of Al are involved, and the hybridization state of Al is sp3d2. So let's go for the question here, and then we'll go for a table that has been introduced here, so which has been as follows. So the question we have, the first question of this particular unit, which is your P block element. The question is standard electrode potential value E for Al3 plus by Al is minus 1.66 volt, and that of Tl3 plus by Ti that is your plus 1.26 volt. Predict about the formations of M3 plus ions in solutions and compare the electropositive character of the two metals. So let's go for the same. Standard electrode potential values for Al3 plus by Al is minus 1.66 volt, and that of 3 plus by T is plus 1.26 volt. Predict about the formation of M3 plus ions in solution and compare the electropositive character of the two metals. So let's go for the solution here. A standard electrode potential that values for the two half cell reaction suggests that aluminum has a high tendency to make Al3 plus aqueous solution ion, whereas Ti3 plus is not only unstable and in solution but is a powerful oxidizing agent, and also thus Ti plus is more stable in solution than Ti3 plus. So aluminium being able to form plus 3 ions easily is more electropositive than thallium. So let's go for the same. For two half cell reaction. Such as that aluminium has high tendency to make Al3 plus aqueous ions, whereas Ti3 plus is not only unstable in solution but it is oxidizing agent. It is a powerful oxidizing agent, and also thus Ti plus is more stable than the solution of Ti3 plus. So aluminum being able to form plus 3 ions easily is more electropositive than thallium. So that is the conclusion here. So we'll go and end up with, and that we'll discuss in the next coming class about the table, and as well as the reactivity towards air and reactivity towards acids and alkalines. All these parts we'll discuss in the next coming class, and hopefully we'll be completing the chemical properties. And so here we're going to end up with. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.